Hi guys, today we are working on solving systems by substitution. Specifically today we are talking about substituting a variable. So we have one equation that has two variables and the other equation has one variable. So what we're going to do is we're going to choose the equation with one variable. And we're going to walk through all these steps together. So I'm going to look at between these two right here. And I'm going to say the 3y equals 15 is the one that has one variable. So I'm going to write that down right here. 3y equals 15. Now, for step 2, we are going to solve for the variable using inverse operations if it needs it. So what I mean here is that the variable needs to be isolated. Or by itself. So what we have to do is say what's attached to my y. What's on the same side of the equal sign as my y? And it's the 3. And 3 is attached to the y. If it's attached, that means we're multiplying, right? So we're going to divide by 3 on both sides. I cross that out because when I think of 3 over 3, that equals 1. So if I draw a line through that, that means it goes away. Because it's 1, I don't have to demonstrate the 1 in front of it. Because we know that y equals something always is going to have that invisible 1 right there. We can multiply anything by 1 and it's itself. So 15 divided by 3 is 5. Okay, so now we have our y isolated. So we go on to the next step. We're going to plug what the variable equals into the other equation. So we're going to plug that 5 in for y in the equation that has two variables. So now I'm looking at this top equation right here. Okay. So we're going to plug that in. I'm going to change my colors real quick right here. I'm going to write down negative 2x. So I'm just writing down the equation right now. Plus 6. Here's where we're going to do something different. Instead of that y, we're going to plug in the 5 or substitute 5 in for y. Okay? And then I'm going to put equals 18. And then over here to the left of number 3, I'm going to put in parentheses. Okay? That's important because sometimes you're going to have to distribute to more than just one number. So like here in this situation, we're going to do 6 times 5. But sometimes we're going to be substituting more. So for now, just put it in parentheses and know that we're going to multiply the 6 by the 5. And just a reminder, we are going to be using, PEMDAS. So it is parentheses, exponents, multiplication, division, addition, and subtraction. And this is our order of operations. Okay, so now we're going to solve for the remaining variables just for step 4. So we have our 6 times 5. I know that is 30. Then we're going to drop everything else down. So negative 2x equals 18. So now I need to get my x isolated to solve for that remaining variable. So we're solving for the x, so we're isolating it. We're going to subtract 30 first. Okay, because the negative 2 is attached to it. So we're going to drop down that negative 2x equals 18 minus 30. So if I take 30 and subtract 18, I'm going to get 12. But I'm going to keep the sign of the bigger number, and that is 30. So negative 12. And lastly, we're going to divide by negative 2, because remember, whenever we have a number and a variable, it's going to be multiplied together. Unless there's a sign between it, they're multiplied. And then we're going to divide by negative 2. And I'm going to draw my line through that again, because negative 2 over 2 is 1. I'm going to do that over here to the side again. Negative 2 over negative 2 equals 1. I know a negative over negative is a positive, and 2 over 2 is 1. So we're going to get x equals, and I'm going to write that right there, even though I know it's going into my next box. I know, again, I have negative 12 divided by negative 2. A negative over a negative is a positive. So I'm going to go ahead and draw my line through that. And then I have 12 over 2. 12 divided by 2 is 6. So now I'm going to put this as an ordered pair. So I'm going to have 6, 5. So remember, your x always comes first. X comes first in the alphabet. X comes first in the ordered pair. Our last step is to check our solution by substituting into the original equation. In this case, I would say to pick the one that has 2 variables. In the future, we'll have equations that have 2 variables on both of them. But for now, we just have this one. So let's just go ahead and plug into our top equation. So I'm going to do negative 2. Instead of our x, we're going to put our 6 plus 6 times, instead of our y, we're going to put a 5 and equals 18. So negative 2 times 6, that's negative 12, plus 6 times 5 is 30, equals 18. Then we are going to have negative 12 plus 30, and that is 18. If 18 equals 18, then we got the correct answer. All right, so after I have gone through the notes and given them step-by-step directions, I think it's real important for students to have explicit instruction to where they can look back and find a way to do that. And maybe that's me making notes kind of like this, or whatever you guys have to provide already. So I'm going to go to the next page, and I have some practice problems. I have one that's easier than the one that I just did, and one that's about the same level of difficulty. I would have my students walk me through a couple of practice problems before I let them loose onto other problems. So, and I wouldn't give them anything harder than what I have shown them or have walked through with them. So this would be a good lesson for me to do, walking into substituting an equation in for a variable. So after we've gone through practice problems and I've got them working either in groups or on their own, I would probably, if I were in person, I would circulate the room and see if I can bridge any gaps and find a way to meet the students where they are at. And then, because some students definitely struggle with even like one-step equations, so maybe reviewing that and bringing in different options and making them think along the lines of, what if they were in a store and grocery shopping and they needed to buy, they had $5 to buy some apples. How many apples could they buy for however much they were per, let's say there were $1.25 per apple. How many apples could they buy? And having them work backwards and seeing what they have to do to solve these problems. So I would definitely be doing that and providing calculators if they need them. some of my students in person right now definitely struggle with multiplication and division. So I would definitely provide that if needed, or find some way for them to be working on improving those skills. So yeah. Also, I typically do my recordings in this platform, and I know that Stride uses Neuro, and I would like to find a way for there to be a good overlap between the two. I just haven't experimented enough with that yet.